Live-bearing mammals, the Therian mammals, determine chromosomal gender using an XY chromosomal system. In such a system, the male is the heterogametic gender, having two different chromosomes, X and Y, while the female is the homogametic gender, having two of the same X chromosomes. Now, other organisms are also classified as having an XY system, such as flies, but it should be stressed that these are not the same X and Y chromosomes. And so, for example, in flies, it is different. The Y chromosome does not confer male gender, but rather it involves the gene dosage of gene products from the X chromosomes. So then to be clear, because that's important for the monotremes, having an XY system doesn't mean you have the same X and Y chromosomes. Birds, snakes, and butterflies use sex chromosomes which are classified as ZW because in these examples, the female is the heterogametic gender receiving a Z and a W chromosome, while the males receive two of the same, ZZ. Once again, the fact that birds, snakes, and butterflies use a ZW system does not mean that the sex chromosomes in birds, butterflies, and snakes are homologous. To be homologous, one would consider, do you see blocks of the same genes in the same order? Do the chromosomes, have the same banding patterns, the same length, the same genes? And as such, the Z chromosome of birds is not homologous to the X chromosome of live birth mammals. However, the Z chromosome is homologous to the multiple X chromosomes in the egg-laying mammals. So as I will describe, egg-laying mammals have multiple pairs of sex chromosomes, and there are blocks of genes with conserved gene order, which are similar in the chromosomes which determine gender in the egg-laying mammals to the Z chromosome, which determines gender in birds. The video playing in the background is simply showing how blocks of genes can be conserved in evolution, comparing those of humans and mice generally. Do male monotremes possess a Y chromosome, which is homologous to the Y chromosome of Therian mammals, the marsupials and placental mammals? No. Fish do not have a Y chromosome, which is homologous to that of live birth mammals, nor do amphibians, nor do reptiles or birds, nor do monotremes. The SRY gene on the Y chromosome of the Therian mammals is the gene which initiates male development. It is a modified duplicate of an older gene called SOX3, which does exist in more primitive vertebrates, but this exists on an autosome of monotremes, a chromosome which is not involved in chromosomal gender. Do female monotremes possess an X chromosome which is homologous to the X chromosome of Therian mammals? No, only Therian mammals possess a sex chromosome which is homologous to the X. Vertebrates ranging from fish to birds do possess homologous blocks of genes which are found on the Therian X chromosome, but they are found on chromosomes which are autosomes, not involved in chromosomal gender determination. So then how is chromosomal gender determined in monotremes? Well, in the platypus, there are 10 sex chromosomes. Females have two copies of five different X chromosomes. So they are X1, X1, X2, X2, X3, X3, X4, X4, X5, X5. So in humans, females are XX, whereas in the platypus, they have two copies of five different X chromosomes. Males, however, have five copies of these X chromosomes, one of each. But then they also have five Y chromosomes, chromosomes which only exist in males. So they are X1Y1, X2Y2, X3Y3, X4Y4, X5Y5. It is not the presence of Y chromosomes which will determine maleness, but rather the gene dosage of genes on the X chromosome, such as the DMRT1 gene. And this is interesting because it is dosage of this gene which also helps to determine gender in birds which use the ZW system. Interestingly, the echidna has a similar system, but there are differences. The echidna possesses 9 sex chromosomes compared to the 10 of the platypus. While some of the chromosomes are the same, others are not. And the monotreme system does have similarity to that of birds rather than the therian mammals, in that genes homologous to the avian Z chromosome used in sex determination are found on the platypus chromosomes X1, X2, X3, and X5. How can such a system be organized in meiosis, which relies on the pairing of chromosomes, if there are so many different X's and Y's? Well, in males, there's a unique thing that happens, which is fascinating. A chromosome chain is formed because each Y chromosome has sections which match and thus can be paired in meiosis with sections from two different X chromosomes. So Y1, part of it pairs with X1, but then part of it can pair with X2 and start to form a chain. Y2 can pair in part with X2, but then also in part with X3. Y3 can pair in part with X3 and with part of X4. Y4 can pair with part of X4 and 5. And Y5 can pair with X5. And so this chain of chromosomes which forms during male meiosis is a unique way of keeping this set together.